Alright, hey guys, this is geometry for April 14th, Tuesday. So we'll start chapter 13. So if y'all did well on your test. Chapter 13 deals with similar figures. So the first thing we have to get out of the way is the definition. It says similar polygons are polygons having corresponding angles that are congruent and corresponding sides that are proportional. If triangle ABC and triangle DEF are similar, the proper notation is triangle ABC with a little tilde symbol is congruent to DEF. And so again, you name it based on their similar parts. So if ABC is similar to triangle DEF, then you name it by their similar parts. So that means the angle A is the same as D, B, and E, and C, and F. So it works the same way as our congruency. The only difference is, instead of doing the equal sign with the tilde, it's just the tilde. Because what that tells you is that these triangles aren't congruent. They're not exactly the same, but they're in proportion to each other. And so that is just the definition, the symbology of it. And so that's important to understand just as far as the definition. So again, similar just means that the angles are the same, but their sides are going to be proportionate to each other. So one's going to be bigger, one's going to be smaller, but it's going to be proportionate. And so the question then becomes, okay, how do we do ratios? And so basically a ratio is where you're going to set up one part over another part is equal to one part over another part. And so basically what we have to be able to do is be able to just do the ratio part first and then worry about how we set up the actual fractions based on the figure. And so if we look at my example up here on the board, we have the fraction 2 over 5 equals to 10 over x. So what happens is these are going to be proportionate. Basically, 2 over 5 is going to be proportionate to 10 over whatever x is. And so to figure out how to solve these, we're just going to do the cross multiplication and then solve the algebraic expression that follows. And so we're just going to do 2 times x. So cross multiply 2 times x gives me 2x. Then cross multiply and do 5 times 10, and that is equal to 50. So I get 2x equals 50. Then I'm going to solve for x. So I'm going to divide both sides by 2. And I'll wind up with x equals 25. So what that means is x equals 25. So what that means is 2 over 5, that fraction is proportionate to 10 over 25. That means the 5 and the 25 are at the same range as the 2 to the 10. And so it's a proportionate fraction. So 2 over 5 will equal 10 over 25. And so x there would be 25. Alright, so B works the same way. You basically can solve for any one of those spots. So the variable could go here, the variable could go there, the variable will go there, or the variable could be here. You can solve for any one of those spots once you have the other three. And so for B here, it's going to work the same way. We're just solving the actual portion, the actual fraction. And so we're solving for x. So when we set up ratios, we're going to cross multiply to find our missing value. And so we're just going to do x times 9. So x times 9 would be 9x by doing cross multiplication. Then I'm going to do 12 times 3 as far as the cross multiplication goes. And so 12 times 3 is 36. So I get 9x equals 36. So then solving for x, I'm going to divide by 9. And so I get that x would equal 4. And so what that tells me is on my x in this problem would be 4. So that tells me that 4 over 12 is the same thing as 3 over 9. And so if you look on the homework that we do, you're going to do 1 through 6. 1 through 6 are going to work identical to that. So you're going to set up the fraction, to set up the ratios, cross multiply, and solve. So that's how we're going to do it. So 1 through 6 are going to work like A and B up here on the board. Alright? The next type problem is going to be like 7 and 8. So 7 and 8 are going to work like C up here on the board. So what they do is they give you a figure and you actually have to set up the ratio. So you actually have to set up the ratios based off the figure they give you. So it says find the ratio of the lengths in the right figure to those in the left figure pre-image for each figure of the similar figures. So find the ratio of the links in the right figure, which is the image, to those in the left figure, which is the pre-image. So we're going to go from basically right to left. So we're going to do this one to that one. So we're going to put this one over that one. And so if you notice, you're going to set up, find which sides are the same in ratio to each other. So the 8 and the 4 down here on the bottom are going to be in ratio to each other. And so you're going to set up that fraction, and it wants to go from right to left. And so it'd be from 4, so you do 4 over 8. So 4 over 8, and then reduce, and that would be 1/2. So 1/2 would be the ratio. So in other words, this one is half as big as that other one. So the ratio would be 4 over 8. So this one over the 8. Now notice, because of the way ratios work, every side is proportionate to its similar side. And so before, you could have done the 4 over 8, or you could have done the 5 over 10. It doesn't matter. You're going to wind up with the same portion, which is the same ratio because they're proportionate. And so that would be 1/2. So that would give you an example like number 7 and 8. Again, they said to go from right to left. So set it up the ratio and then reduce it. Now the last few problems, 9 through 12, are going to work like example D on the board. And so what they do is they give you one figure and they say, okay, tell me what the lengths of the sides would be for the other figure. And so they give us this triangle here to tell us these sides are 15, 9, and 18, and they want me to figure out what the other sides are that are missing for the other triangle. And so the first thing you want to do is set up the ratio. So do this on this one, but do it with the numbers you have. So in other words, don't put a variable in it to start with. Actually get the ratio numerically. And so notice that I have the x here. So I don't want to do the 9, have the y there, I don't want to do the 18 yet. So I want to do this bottom because they both give me the numbers of that so I can actually give the ratio. And so if I went from right to left here, the ratio would be 5 over 15. So 5 over 15 would be 1/3. So 1 over 3. So that's the ratio. So going from right to left, it's 1 over 3. So from this triangle, triangle 1, triangle 2, it is 1/3. So that's going to be the ratio I use to solve for the variables. So I'm going to use 1 over 3 from 1 to 2 equals, and then I'm going to do from 1 to 2 with one of the other sides. And so I'll do x first. So I'm going to go from x to the, and its matching side was 9. So I'm going to put the x over the 9. Remember, I did 1 over 3, x over 9. Basically, you have to go the same way. I could have went from 2 to 1, but if I did from 2 to 1, I would have to put the 9 over the x. So that matters. You can't flip-flop it. So once you start going from one to the other, you have to finish that through the entire process. And so at this point, you could just cross multiplying and solving for x. So I'm going to do 1 times 9, which is 9, and then 3 times x, which is 3x. So just cross multiplying. So then solving for that, x equals 3. So my x would be 3 for this problem. So then the same thing for y. I'm going to do the 1/3 equals, then I'm going to do y over 18. Cross multiply. I get 18 equals 3y. Divide by 3. And I get y equals 6. And so my y would be 6. And so again, it's just setting up the ratio, then working it through. But remember, you just have to go, if you go from right to left, 1 to 2, then you have to do that for all of them. If you go from left to right, then you have to do that for all of them. So you can't flip-flop your order, because that matters, and that will mess you up and give you the wrong answer. So find the ratio, then plug in and find your missing variables. So that'll get you through 9 through 12. And then the last few, 13, is just a definitional one. So, like I said, the way you name them matters. So if I said triangle ABC is similar to triangle DEF, that means the angle A is congruent to angle D, angle B is congruent to angle C, angle B is congruent to angle E, and so forth and so on. And then the actual sides, so AB would be similar, proportionate to DE. And so you just work it through. So that'll do 13. 14 is just a thinking one, and then 15 again is just a thinking one. And so do your homework for this section is going to be 1 through 16 on page 538 and 539. So 1 through 16, that should conclude today's lesson. What I need you to do those. If you have any questions, get with me. This is foundational. We have to have this down, or else the next few lessons aren't going to make a ton of sense. So make sure we get this down. Thank y'all. Have a good day.